my screen? Stream's running? Awesome. Cool. Well, we have a bit of an agenda here, so I'll just take a few minutes to go over the agenda, and maybe there are a few other topics that we can brainstorm to add to the agenda. Definitely want to keep that open. So figured we would start with some short introductions. I think most of us here know each other, but if anyone has any additional work on quadratic funding, I know Owaki, you mentioned some researchers have been reaching out to you. Danilo, I believe you've also been in touch with a few people who are working on it. So we expect these people to come into these sessions at some point, and definitely want to leave a bit of space for them to intro their work. And also any topics to the agenda. Is there anyone here who feels they need an intro or would like to take a couple of minutes to say hello and what you're interested in here? Or who do we have here? Oh, TJ, nice to see you, man. Craig, cool. Leon, nice to meet you. If anyone wants to say hello, feel free.
Hi, Jeff. It's Jay.
Nice. Cool. So I want to just run through the agenda quickly. We were going to go over, for anyone who hasn't been involved, the context of this research initiative thus far. We have a couple of diagrams to walk through about the immediate applicability of this research, as well as a broader research roadmap. And then we thought we would jump into some of these open discussion topics. So a brief overview of the QF mechanism, how we define optimization problems, and some of the specifics of how we can get more detailed in examining various optimizations in this area. Talking about the pairwise algorithm, some of the trade-offs involved, and there is space for more topics. If anyone has anything of particular interest to add to the agenda, we can add them now or as the topics come up emergently in conversation. Awesome. All right. I will turn it over to Z to give us a bit of background and context on this research initiative, and I'll just zoom in on these so we can see what they are. Actually, I'll switch over here because I think this will be better.
The other plot would be good. Cool. So I'm not going to belabor this, but just to understand that the Block.Science and Gitcoin collaboration is a research project that's focused on this application of detecting collusion, which is more broadly part of the review process. So over the course of a Gitcoin round, a wide range of contributions are made. There's some there's some terms and conditions for participating, and there's some understanding that is a normative interpretation of behavior that ultimately determines that kind of oversight or stewardship by the Gitcoin team. And this is heavily based on data and algorithms. And so the work here is very focused on collusion detection, or as Owaki says, the collusion hunters. And so we've been focusing our work on first some data and tech infrastructure with cadCAD and historical data to build out tools for identifying for backtesting and identifying algorithms associated with collusion detection, which would ultimately affect the payouts in quadratic funding, presuming that we get past a point where algorithms are suitably backtested to be used in a production environment. Currently, though, we're doing some scientific work to define and design and evaluate collusion detection algorithms. So you can jump down to the other plot or over to the other plot.
How do I get out of presentation mode? There we go. Oh, maybe not. There it is.
There we go. Cool. And so in this one, we just have sort of an overview of the research that we are doing. The yellow box is sort of the research infrastructure, the data collection and cleaning, and cadCAD model that we use to generate contribution graphs, so time-varying contribution graphs from historical round data. And then we've been working on these grant neighborhood subgraph and subgraph rewiring optimization problems as part of our research into collusion detection. And we've defined this in two steps. One, which is a sort of reduced or simplified version of the problem using relatively narrowly defined subgraphs. And then we have a relaxation of that problem, which we iterate to or intend to iterate to in order to meet the needs of a specific flagging algorithm for use by the Gitcoin team. However, this isn't the only thing that you can do. And in fact, we have, through our discussions with the token engineering community and with the Gitcoin team, identified some other interesting areas of research that could be followed based on this data and these tools. In particular, we're pretty interested in Gini coefficients, and also we've identified this sort of preferential attachment model through which the sort of graph builds itself over time, or the temporal dynamics. Some people have highlighted the issues with saturation. And so there's a range of things in orange that we've identified as other fun research areas that if people who are joining these calls are interested in participating, we'd sort of advocate for and even provide maybe some support in pursuing research on those vectors in these open source, open science repos. And that's pretty much it for context. We'll get into the details a little bit of what we're doing, but then further open up the floor for discussion with others, because part of the reason we're doing these open sessions is to sort of take our work and demonstrate it a little bit to provide fertile ground for other people to contribute in their own ways, not necessarily directly to our research project, but maybe, but also to their own research projects using some of the same open source infrastructure that's been pushed into these repos related to data and models, because it opens the door to lots of research directions. So that's my context setting. I think I probably pass the floor to Danilo, who can give some more on our work. And I believe in about 15 minutes, we'll have Jaja, who also works with our team. But I think she's going to share after she gets here.
Sure. So I'll share my screen here. Let me. So I'm sort of running a budget that for some reason it's quite easy sharing, let's say, just one screen, but two at once. Let me see if I can work around that. Actually, I did run it into that. Okay. Okay, now I think it's working. Are you all seeing here the investigate for optimality gap as indicator?
Yep.
Okay. So just to do a pass about the current status of our work and let's say what are our immediate goals and so on. As I said before, the main thrust of the collaboration between Block.Science and Gitcoin is to identify, let's say, metrics and methods that could use for flagging collusion. And this is let's say, this can be a iterative problem in the sense that, let's say, when you talk about collusion, you are talking about, let's say, a private intent that not necessarily is expressed through public structures. So what happens is that we need to adopt some tactics to try to identify that. And I think that we've been doing over the last iteration is to actually to see what's the consequence if a colluder actor actually gets successful in its attack. So one thing that we have defined, and we think that code capture, let's say, it could be a measure of success of the collusion attack, is what we call the optimality gap. So the main idea of that optimality gap is the following. If you have organic grants and you have, let's say, organic communities, most often let's say the network structure behind that community is not necessarily very optimal, in the sense that, let's say, if you rearrange the way that you contribute, if you, let's say, make several users donate to just one grant, or do some kind of, let's say, some kind of strategy. If you do that, you could, for example, get way more match, even if, let's say, the contribution amount in total is the same.
Danilo, the
Yeah,
same
go on.
thing that we talked about in the hack session. I think the first thing we need to do is define what the optimization problem is. So we are posing it the following way. Suppose suppose that the activity to donate is intended to optimize the extraction or the total match. You can kind of take the interpretation of contributions as if they were solutions to the optimization problem, and then measure them against some optimal strategy for allocating the same resources such that the extracted match funds is maximized. And although we don't know that people are doing that a priori, we can take a subgraph, we can interpret that subgraph as if it's a problem. And then optimality gap is about comparing the extracted match in the real event against the extracted match in the optimal allocation of those same resources to maximize the funds taken from the shared pool. And when we measure it that way, we're not actually saying that people solved that optimization problem, but we can get a sense of whether their behavior is sort of suspiciously efficient by looking at how close to the optimal they are. But in order to talk about optimality gap, we do have to impose the interpretation of the activity as the solution to an optimization problem. The nice thing about this is that we can impose this lens irrespective of whether that's how they actually got to that activity. The last point on that, though, is that ultimately all this does is flag things because they could later be reviewed for whether or not it just happens to be a special case that worked out that way but seems natural, versus saying, hey, by the way, this is kind of sketchy. These people were really just trying to take funds. So I'll hand back the floor, but I think it's always important to talk a bit about how we get to the lens of optimization in a setting where it's not guaranteed that anyone actually solved this problem. It's a way of presenting the graph as the solution to an optimization problem, even if it wasn't.
Yeah, that's right. And the idea of that, let's say, of having a look at that metric is to, let's say, is to look at the consequence. So let's say if we have a grant, for example, that is very close to optimal, it's very efficient, it can be flagged. But of course, if it can be that, let's say, it's coincidence. But what I mean is that, let's say, a working hypothesis that we do have is that colluders are going to adopt a very efficient strategy. They are going to adopt an optimal strategy. And of course, this is our hypothesis. The way that the workflow, let's say, the way that the scientific work works is by that. Let's say you have a set of definitions. And I mean, those definitions are, for example, how you define those subgraphs, if you are going to, let's say, get the neighborhood grants, if you are going to use community detection algorithms. Right now, we are using a neighborhood subgraph definition, which is a very narrow definition, but we have scope for, let's say, for using more sophisticated algorithms, like, for example, community-based ones. So we have that definition of subgraph, which we are interested. And we have also other definitions, like, for example, when you look to the metric of interest to a subgraph or to a graph, you are talking about quadratic match. And when we talk about, let's say, the optimality gap, you are essentially getting the difference between the quadratic match of a community, the real quadratic match, the actual quadratic match, versus the quadratic match that community would get if they, let's say, if they rewired their graphs so that they could extract as much as possible from the network. Like, for example, changing the collaboration patterns, maybe collaborating lots to one grant, or maybe distributing. The thing is, that optimal subgraph, you don't know it a priori. The only thing that you have when you look at the data is the, let's say, is the quadratic match of the, let's say, of the actual structure. But to know the what would be the quadratic match if the structure is optimized, it requires uses of some algorithms, like, for example, gradient descent, simulated annealing, gradient deload, genetic algorithms. And I'll go a bit about that because, let's say, the last working session that was today was actually to implement a simulated annealer on our cadCAD model so that we could calculate the optimality gap. And of course, there are also other things like genetic algorithms that could be very promising. But anyway, getting back here to the research plan, the idea is that, let's say, once you have those definitions, and once you have a definition of what is an optimality gap, that is this difference between the optimal and the real one, you can have hypotheses. And the working hypothesis that we have is, let's say, when you look at that distribution of metrics, you are going to see something like this histogram here. You just need to replace, instead of having graded distribution, you would have optimality gap, and instead of number of students, you would have number of graphs. And the hypothesis that we have is, let's say, we are going to have a very large peak here that is about organic grants, non-colluding grants. And we are going to have a small peak here that could be interpreted possibly as colluding grants. It could be, let's say, grants that we could flag. And it's important to put emphasis on the hypothesis thing, because when we, let's say, go through the scientific workflow, the main thing on any scientific research is to be actually what people call falsifiable, in the sense that, let's say, your hypothesis can be wrong. You can be quantitatively wrong. And that's the idea of putting the hypothesis so bluntly, actually. Because let's say we want to know if we are wrong or not. If we are not wrong about that, there are several applications that we can make from it. And if we are wrong, there are several research directions that we can continue the iteration. And actually, we have put here, let's say, some applications that we could do with that. Like, for example, if our hypothesis is confirmed, we could, for example, create policies that make use of that. So that, for example, we could flag potential grants for human review, or this could, for example, fuel further research on that, because we know that this is an interesting metric to look into. But if this hypothesis is false, then we have some options. Like, for example, change your definition of community. Instead of using the neighborhood subgraph, we could use another algorithm or another way to define a community. We could change our hypothesis. Instead of testing for a bimodal distribution on histogram, we could, for example, suppose that there is a spectral separation into 10. Or we could say that, let's say, it follows some kind of power law. Actually, there are several possibilities, but we always need to, let's say, keep track of what makes sense. We could also change the metric, let's say, instead of calculating the quadratic match, or instead of, we could think of maybe another metric that could make more sense. And of course, those are directions that it's possible to take, and this is not exhaustive.
I would point out that the approach that we've taken, though, because it's been broken down scientifically, is inherently more modular. So the expectation is almost always that something will end up not being perfectly confirmed. But then by modularizing the work, both the tools and the approach, by breaking down definitions and being clear about assumptions, it's far faster to iterate, because you swap out one definition and then you run the analysis again and you sort of learn something each time, as opposed to having to build a whole new infrastructure for a minor change in definitions or metrics, etc. And so that's actually an important part of the upfront work in this project, in building like significantly more modular tooling. I don't know if that's just for people who are joining, and we were hoping to incite people to also collaborate and do their own stuff, not necessarily what we're doing. It's important to know that you can kind of grab some of this stuff and swap out and try your own things. If you, for example, had your own hypothesis that differed from ours, maybe associated with your swaps on some of these definitions or swaps on some of these metrics. Anyway, sorry, go ahead, Danilo. I want to kind of be inviting in addition to just presenting.
That's right. And I think this was a great point, because I think, let's say, just to finish that, I would tell that there are several next steps that we super invite the community of researchers to tackle along. And I mean, this document is public. But anyway, I think that I would also like to add is about how we are doing. What is our method for doing that? So let's say we are using open source tools. We are developing open science, in the sense that, let's say, we are doing public working sessions. We have this academization session where we can discuss the directions, share ideas. We have the hacking sessions where we actually, let's say, get our hands dirty on the code. And I think that I would like to put emphasis, and I think it's a strong point of having this modularity, is that, let me see if I can share here. So Are you guys seeing a GitHub repository here?
Yeah.
Yeah. Okay. So, for example, the way that we are approaching is that we are developing this science through an open source way, in the sense that, let's say, our results, models, methods, and data are going to be published on GitHub repos. But we also adopt that open source approach of also working in the open, also sharing our minds in the open. And for example, suppose that you are a researcher and you don't agree with some of our definitions. You think that there is a better way, or maybe you just want for, let's say, have a parallel workflow. We try to, let's say, investigate one application of a definition, and you can try another. If you want to change any definition about that research direction, what you do is to get on the GitHub repository. You go to the Optimality Gap folder. That is a folder that we are encapsulating several of our definitions, optimizers that we are using for this research iteration. And I think that we are going to have a lot more folders in the future because research keeps growing up. You would go to the definitions.py file, and then you could change, for example, let's say, what is your metric of interest? Like, for example, you could change, for example, the definition of the optimality gap. Or else there is another place here. For example, here is define the neighborhood subgraph. You could change that so that instead of invoking the neighborhood subgraph, it could, for example, invoke maybe a community detected by fluid. What I mean is that, let's say, our definitions are here shared, so it makes very easy to people to, let's say, if they want to change that research plan and make it their own, it's just a matter of also working the repository, change definitions, and making it apply to the new directions. And I mean, I think that's it for, let's say, the state, for the overview of what we are doing. I mean, I would like also to leave the floor here if anyone has any questions about that, or any comments. So, yeah.
So I want to make sure I'm understanding what's happening. So it seems that you are looking at what an optimal outcome would look like from the perspective of a particular actor, and then determining how close they came to that optimal outcome as an indicator of possible collusion. Is that accurate?
It's richer than that. It's not just in respect to an actor. I mean, you have to think about it in terms of a subgraph, which is comprised of grants and contributors. And you can have simplified versions that look at one grant and many contributors, or you can move on to having multiple contributors and multiple grants. But ultimately, it's like taking a slice, a subset of the contribution graph, looking at the total resources allocated, which are edges in a sort of bipartite graph from contributors to grants, and then looking at if you took the same group of people and the same and the set of grants that they're contributing to, and if they rewired the way they donated the same money in order to maximize the take on those grants. This is a constructed optimization problem, or that's why I was saying it was an interpretation, because we don't actually expect that people are solving this problem. But if they were, like, explicitly, but if they were colluding, then effectively their solution would be very close to optimal in this problem. They would be maximizing the share of the pie, the funds from the matching pool that's going to this small group of grants, by strategically taking their assets and like spreading them over grants in a way that resulted in maximal matching. And in fact, we've played around with this a little bit analytically and computationally to see that there's actually quite a bit of sensitivity here. There's a notion of a sort of grant Sybil or reverse Sybil, which comes from not making up fake identities, but just splitting your grant into lots of tiny little grants. Because what ends up happening then is the same group of, say, N people splitting funds over M grants results in a bunch of individual things with high match. So, and this is just one of many things that might arise. And so when you look at the efficiency from a dollars in to dollars out of the match pool type metric, in a way, the optimality gap is like a richer version of this. It's like, what's the most we could have pulled out of the pool as a group if we had efficiently allocated money, and by going around and drawing little subgraphs and then rewiring them to maximize their how much they suck out of the pot, you can see whether or not the real graph is getting a similar amount out of the pot than the best graph. And if you're close to the best graph, then there's a reason to at least inspect whether this is honest behavior or potentially some sort of behind the scenes attempt to unfairly withdraw from the shared pot.
Thank you for that. I have a follow-up question, if I could, based on what you've said.
Go ahead.
Sure.
So the optimized subgraph, is that known based on structural properties, or is that optimal solution found via the meta heuristics that you're discussing?
Meta heuristic. So as of right now, there's a notion of like there's sort of a naive interpretation, which would be like if you knew nothing else, you would expect optimal to be constructed by just sort of splitting your funds evenly across, like, like it's like n, if there are n actors and m grants, then you would take your total sum of funds from all of those actors and split them up into n times m buckets and spread them out evenly. But that assumes no other behavior. In the presence of the rest of the organic activity, there might be other solutions, and it's a sort of combinatorial, messy optimization problem. So we're using the sort of meta heuristics to discover the optimal rewirings. And actually, Danilo can probably show us a little bit of the work that was going on in the hack session earlier today, implementing a simulated annealing approach to discovering those optimal rewirings, because they serve as sort of a benchmark, right? You compare the take that a group got to the largest take they could have gotten, and that way, if they're really close to that, it's an indicator they may have optimized. Whereas even someone who got a lot of money might have gotten much less than they would have if they had done some sort of optimal allocation, according to this rule.
Thank you.
Yeah, and about meta heuristics, just to be clear, we are using meta heuristics for this first iteration, but let's say one of the things that we've put as a possible research direction is exactly to, let's say, to see if there is a deterministic way of getting that optimal solution. This remains to be explored, but let's say for this iteration, we are using meta heuristics, specifically simulated annealing. And I can share here my screen briefly. So are you guys here seeing?
It's loading up.
Okay. So
Good
for
now.
example, yeah. For example, this was the agenda for our hacking session today. And the goal today was to actually get that optimality gap for each grade. So, and the thing is that, let's say, those meta heuristics, they didn't have any implementation on Network X. So we had a sort of a fun session because, let's say, I was joking. It was a double open session because we were building open science and also building open source at the same time. Because what happened is that we forked the Network X. We've created a new folder here called Edge Rewiring. And we were implementing here some heuristics, meta heuristics, according to some articles that we have stumbled on. So, for example, here we were implementing a edge rewiring optimizer that uses simulated annealing. And I mean, everything of that was actually, let's say, built maybe 100 before now. But anyway, this is just to showcase, let's say, how things actually work. And the idea is that, let's say, we do to simulate annealing optimization so that we can get at the optimal subgraph and we get the optimal gap. And I mean, I think that's it for it. Also, Jaja is here, so she may have some interesting bits that she could share for some discussion points. Any more questions?
Hi, Jaja. I don't know if you caught where we're at, but we went through the agenda up to, I think, going over the hack session from this morning or this earlier this afternoon. But I wanted to make sure that you had time to talk about metagaming, simplicity and metagaming, and some of the stuff that you presented in R&D earlier this week.
Cool. So I should probably just present the last few slides of my R&D slide deck, right? Should I go for something like, should I kind of go for more of like talking about the different ways to game quadratic funding, or
Yeah.
like how?
I think you could probably spend a little bit of time on the different ways to game quadratic funding, and then I think the key though is to do that for motivating. I think the most important point is the point that you reach at the end around the role of simplicity and how it relates to metagaming and fairness. But by all means, talking about different kinds of attacks is really helpful.
Okay. So let me share my screen.
It's between the video and the microphone at the bottom of the screen there.
And I should choose simulations as a channel, right?
Yes, correct. Yep, got it.
Oh no, what's going on? What screen am I looking at right now?
You're sharing Discord, I think.
Oh no. Okay.
It's a meta share.
Okay. I think the problem is I have an external monitor too. So are you guys saying anything? No.
I just see a black screen at this.
Okay. Let me.
Sorry, we're learning new tools.
Actually, I'm just gonna talk about it.
Why don't you send the link to me or Jeff and we'll screen share it for you?
Cool. It's oh god. Okay. This is a keynote slide. Let me.
Yeah, I have Keynote. If you have a link to iCloud or something, I'll pop it open for you.
Okay. I will just PM you on Slack. With the
Perhaps
the-
I can ask a question
Sorry about this.
to Kevin in the meantime. Kevin, are you there still? Or
Hey,
hope Hey, great. So we had the AMA session on the research group today, and we talked a little bit about optimality gap and having this as a signal for potential collusion. I mean, it's not a proof. And of course, there's a gray area of what is collusion. And then rather, the question is perhaps what's the KPI or strategy for Gitcoin grants? So once you have the signaling, what are your plans? What are you going to do with it?
great question.
And what are you aiming for?
Zargam and Jeff have done a good job of letting me know that collusion is a subjective thing, and so they've been very clear to me from the beginning that there won't be an objective math answer. And so basically, I think that the answer is that so Vitalik, Glenn, and Zoe identified collusion and Sybil attacks as the Achilles heel of quadratic funding. And so, as the largest quadratic funding application in the world, I think it's incumbent upon us to make to make progress on both of those problems. And we're doing a lot of work to integrate different anti-Sybil mechanisms into the code base. Obviously, doing a lot of collusion stuff here. And I think that what I could see doing is if there's a category of types of collusions or things that smell like collusion, I'd love to like if there's let's say if there's 2 to 5 categories of things that look like collusion, I think we would love to start a debate with Vitalik and Glenn and the wider Ethereum community about which ones match our values and which ones don't. And that would be sort of an informal part of like off-chain governance in deciding what types of collusion we want to guard against and which ones are okay. And so I think that you should just be focused on informing the discussion, and then eventually that discussion I think will evolve into some sort of decentralized court system, and we'll have some sort of algorithmic governments, or like we'll have some sort of policy in which a court could decide what type of collusion is legal and what kind isn't, and we just have to sort of inform that discussion in that court. Is that fair? Is that valid? Like, I guess it depends on if there's 2 to 5 types of collusion or if there's like 1,000 types of collusion, and how do we inform the discussion is sort of the question I have.
Yeah, I think it's of course it's definitely interesting if there might be a version of algorithmic governance to it, but I think there is definitely a process in how to define collusion to make next steps. Okay.
Okay.
Great.
So I mean, how can I guess, like, let me ask you this: how can I facilitate moving that forward? Like, should we run like a mock court in which we talk through a bunch of examples, and I'll be the judge and the jury, and we can kind of like learn from that, or like, just let me know what you need from me in order to inform the discussion.
I think the first step I think is really valid is once you have, we have data on particular rounds, so we will be able to identify specific grants that look like this could be collusion, and the opposite side. And it's definitely worth having a discussion with those grants, how they approach Gitcoin grants, to have a better qualitative insights on, okay, is there a certain pattern? Is there a certain maybe point in the life cycle of a project? Is there a certain community related aspects? And what do we want to support and grow, and what do we want to say avoid as grants? I think that's an important insight too.
Yeah, totally. Sorry, I didn't mean to cut you off. Go ahead. Okay. Yeah, I mean, I think that pairing up the quantitative data with the qualitative data and just sort of using our own community, like our nose, for what's a good Ethereum public good and what's not, may yield some interesting insights. And yeah, so I'm keen to participate as soon as that conversation is ready.
Awesome. I got the screen share up if people can see it. I'm gonna give Jaja kind of verbal control, and I'll just navigate through her presentation at her at her request. So, if you're ready to go, I can follow your lead.
Okay, cool. Thank you. So I would assume like all of you guys are pretty familiar with the quadratic founding model. So would you mind going down one slide? One more, one more, and one more. One more. One more slides. Sorry, up. Slides number 6. Yes. So, like basically, this, as you can see on this quick visualization, the ways of quadratic founding, the default quadratic founding work is that you take the square root of each contribution and then you add them up, and then you take the square of that. So in this visualization, each green square is each contribution. You take square root, which is diagonal, and you add them up. It's a diagonal of the big square, and then you take square, so it's a large square. But this visualization makes it pretty easy to say that if you reduce if you increase the number of green square, you would eventually have more and more yellow area, which is a matching fund, and less and less of the green area, which is the original contribution supposedly by the crowd. So this kind of leads to so there's like different types of collusion problem, and one of the very easy to do one is basically divide yourselves grant to like tiny green squares, so that you will basically attract a lot of matching funds, but with a limited amount of input. So if you don't mind going down to slides number. If you don't mind to go to slide number 15. So of course, one way to deal with that is the solution proposed by Vitalik. It's called Pairwise Funding. So as you can see, kind of looking at the red circle there, you can see instead of seeing the red, the yellow part as its entirety, you see this tiny yellow square as a match between fund I, which is one green square, and fund J, which is another green square. So if you like add the if you add a parameter to it, then potentially you will be able to identify if people are kind of contributing to multiple funds, but with like a bunch of like they try to coordinate small funds that contribute to a specific subset of funds. But the problem with this type of detection, if you don't mind going down one more slide, is that potentially it is like punishing the collection features, which encourage people to donate to a pre-selected collection of funds. And those are just two cases of potential ways of collusion and detecting collusion on a individual levels. And one of the trends that we see in the past few rounds of Gitcoin funding is that potentially the funding collusion is going more and more complex. And the way to deal with that complexity, if you don't mind going to slide 21. One more. Is that the problem with that is there will be a more and more complex way of preventing collusion, but potentially you would have to design more and more complex way of detecting and preventing collusion. And this basically leads to the escalation of collusion, and also creates more and more information asymmetry for people who have the motivation to detect collusion, to learn about new ways of collusion, and people who don't. Can you go down one more slide? Thank you. So there's already kind of evidence showing that most users that use Gitcoin don't necessarily understand how like quadratic funding works, let alone like pairwise or like this more complex way that we're proposing to detect collusion. And the problem with that is the people who are motivated to understand collusion or like new ways of collusion are usually malicious actors. And can you go down one more slide? And people, so basically you are creating information asymmetry, and only people who are motivated to understand the information are those who have malicious intent. So what would happen is that the game would not stabilize itself, but instead only people with more information are more likely to game the system than people with less information but good intent. So credit to Joseph Hong to suggest kind of using more simple mechanism to balance the meta game. Because if you have a very simple and transparent way of detecting solution, Or if you can make your way of detecting collusion very understandable to all of your users in like a very short time, people would know what would happen if people collude, right? So the idea is not to know how to collude or know how, or not knowing how to collude. Is I know that you know that I know how to collude. So basically, if everyone understands what the strategy of collusion looks like, there would eventually evolve a balanced game where people know who is colluding, and it's easier for the community and the crowd to catch collusion. And there's several ways to go about it. I think one of the reason that we're trying to be very transparent about the process is to really help people establish that understanding. And another way is potentially, I think using algorithmic and graphic way of detecting collusion is really helpful. And the way to make it even more understandable is potentially building like visualization tool or like interactive tool that help people to understand what quadratic funding looks like, how would their each individual contribution impact the overall funding scheme, even like in real time, and also empower them to catch potential collusion. And also, there's a more kind of social solution that is, instead of empowering full decentralization, which is like very tempting, you select or like choose groups that have trusted selection of projects by trusted parties. So it can be groups, it can be a person, it can be a influencer that people trust, and that even though that kind of reduce the decentralization a little bit, it helps people to keep track of what's going on and kind of create a more social dynamics that prevents people from doing collusion. And yeah, this is basically an overview about potential types of collusion and ways of preventing collusion. I wonder what your guys' thoughts are.
I wanted to add one thing too, since you're talking about sort of simplicity of solutions, and obviously we were just talking about something that was, pretty complex. And I think there's a really important bridge here, and that what we're trying to do is construct a metric that is really closely aligned with the spirit of the system, where it should be easy to tell at first order whether someone is colluding under this metric, or the metric relates closely to what would one thinks of as collusion, and in particular the effectiveness of the collusion. So if you're using an optimality gap technique, basically what we're saying is, like, have you optimized for input output efficiency, the amount of capital in equal to the amount of and the gain in terms of the amount of capital out. And when we use that heuristic, although it is maybe somewhat sophisticated to compute, it's not actually that sophisticated to intuit or understand that collusion amounts to basically maximizing your extraction, as opposed to just sort of organically donating to the places that you want to. And it's not necessarily like we're saying it's the best or only solution, but bearing in mind that with awareness of the complexity as a potential risk towards fairness and this sort of escalation problem, there's a sort of emphasis on, even though we're constructing a metric, trying to construct something for which literally, if you were to game the optimality gap metric to reduce your optimality gap, in order to avoid detection, you would necessarily be reducing how effective your collusion is. Basically, you'd be reducing the rate at which you turn money in into money out in order to avoid detection, which, although it might not prevent people from trying to like hug the line and sort of extract without quite tipping over, it does mean that they're necessarily reducing the effectiveness with which they extract money in order to avoid detection, which, if anything, is going to be a metagaming dynamic. You want the metagaming dynamic to be literally get less money, or get less extraction. So just as a point of clarity, like, we're kind of trying to hold both of these things in our mind at the same time, both being sophisticated with our tools, but also avoid this sort of perpetual escalation, like, sort of problem. I don't know if that makes sense to people. Like it's a trade-off dynamic, right? We can't necessarily satisfy everything we would want to satisfy concurrently, so we're kind of exploring the trade-off space.
Super cool. I like how the result of that is, pushing people back towards more acceptable behavior if they are to avoid, collusion detection and punishment, or, being removed from the platform, or whatever the other, collusion prevention strategies are. Then we're saying, you have to be less efficient with value extraction, which is basically what everyone else is doing, engaging organically with Gitcoin grants. Very cool. Awesome. Well, we are almost at the end of our session. We have time maybe for one more question if there is one. Otherwise, I can drop notes or a link to the notes in the Gitcoin chat. Recordings for all the calls today will be coming soon. And yeah, there's lots of exciting more research coming in this area. Really eager to have everyone's time and attention on this important topic.
Yeah, I wanted to end with a call to action, because although we've largely presented our R&D, obviously we gave a summary of some of Jaja's work. We definitely didn't cover all of it. She's been exploring different types of attacks and some of the hack sessions and whatnot. We continue to invite people to participate in our work, but because the infrastructure, the sort of data and models are in an open source repo, that means that anyone who's interested in this kind of stuff can kind of grab the materials and run in their own direction, because we really want people to understand that this kind of platform governance is most effective when it's inclusive, in the sense that it's not one group of experts deciding or anything. It's to kind of Jaja's point about the sort of decentralization comes from people participating and understanding as a group, not just like some experts in a room somewhere.
Yeah, before we end, maybe I have a short question.
Absolutely. Go ahead.
Maybe quickly to myself, I'm a master student from Maastricht, and this point that I'm making is not very much related to what you just talked about, but it is related to quadratic funding. So basically, I was introduced to quadratic funding from over a friend of mine a week ago or so, and I came to a finding, or I had an idea where basically, in the same way that we are encountering problems in expressing our interest due to interest conflicts in ourselves, in our opinion, I thought businesses face similar challenges when we're talking about open innovation, more specifically in like early stage scientific, very much scientific stages of acquiring knowledge. And so I thought maybe this is a good idea to base my master thesis on. And so I'm planning on writing a master thesis about the position of QF in open innovation, basically. And yeah, so what I would like to do is take Gitcoin grants as an example of quadratic funding, to see how is this working, how are incentives, relations between different agents or actors, and then make some comparisons, or rather, I don't know how to say, but basically comparison to other settings, and conclude opportunities and also limitations for quadratic funding outside of the Ethereum ecosystem, or outside of blockchain even, or the blockchain sphere. I don't know, greater. I hope this was not too long, but maybe what first of all, what do you think about this? Is this a valid question to make?
It sounds interesting. I think other people, I don't know, Kevin may have some thoughts.
Certainly seems I messed with my Discord. Hopefully you can hear me. But yeah, it seems interesting, Constantine. I'm really interested to think about how we could work together on this, and so um, keen to learn more. Maybe you and I can DM between now and the next session.
Yeah, that would be great. I would really much like to, since I only know about quadratic funding for 1 week. Obviously, I'm first of all, it makes me an amateur about quadratic funding, but it also makes me uh, not being able to direct myself and find the things that I can look at in terms of quadratic funding. So a little more discussion would definitely help. So that would be great.
Cool.
Yeah, there are some channels here on Token Engineering that I think that it could provide several good directions. Like, for example, we have the TA Gitcoin, where we have asynchronous channels. If you go to the working sessions, we'll be directly handling the quadratic funding in the sense that, let's say, we're handling the code that actually does the matching. What I mean is that there is a full area of that. And if you go to the notes, actually there are some suggestions there. And I mean, welcome to the rabbit hole.
Yes, we definitely like exploring rabbit holes together in this space. I have a few links to send you as well, Constantine. I think most of them are from Owaki. You know, they have a great website. WTF is QF. There's Owaki actually shared another researcher's paper just this morning. So yeah, I think there's some links. I'm sure Owaki will hook you up. I'm happy to drop a few in the Discord channels as well. And yeah, any other questions? I'm sure we would be happy to field them in the Discord and discuss further in our next call.
Maybe one last point on next calls. I think although we've presented some of our work and will in the future, another thing is if people are really interested in this topic, would feel free to reach out if you want to be presenting, because if you're doing work for your master's thesis or one of the other people who's been writing papers on QF is going to come, like this session is not designed to be us like just presenting our work, but rather creating a space for researchers interested in QF as a mechanism. So we want to make sure people feel welcome to ask for time. Just because we're kind of coordinating the sessions doesn't mean we need to monopolize presentations.
That sounds very good. Thank you for having me like that.
Absolutely.
We could call it. We're 5 over, but about an hour. I think we started a few minutes late. So thank you everyone for joining. Feel free to continue to discuss in Token Engineering or Gitcoin Discord. Reach out to us here. We're just going to keep hacking, and obviously watch out for the notifications for the hack sessions, because I think the hack sessions that Danilo's led have been really fun, and actually Angela has also been leading some sessions in the Token Engineering Academy related. So really just expanding knowledge and understanding to improve sort of community involvement in this platform.
Great, thank you.
Thanks, everybody. We'll see you next call.
Thanks everyone. Looking forward to read the notes on the Discord. See you in there. Bye.
Bye bye. Until next time.